Warning: the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is a continuation in a series, pun intended, on sequences and series in pre-calculus. You should have just finished my video on an introduction to sequences, and now we're going to talk about a very special style of sequence called a recursively defined sequence. This shouldn't be such a long video, maybe about 4 pages. So not too terrible. Recursively defined sequence. Well, a sequence in which terms depend on previous terms is called a recursively defined sequence. What do I mean by terms that rely upon previous terms? Well, it could be something like a sub n is equal to a sub n minus 1 plus 1/2 a sub n minus 2 squared, or something like that. That nth term, let's say n is 3, it requires us to know a sub 1 and a sub 2 because we're going to add a sub 1 to 1/2 a sub 2 squared. And so that's how that sequence would be built. It's built on its previous terms. One of the most amazing sequences within all of mathematics is the Fibonacci sequence, and that is a recursively defined sequence. We'll talk about that in this video, but I have a full 2-hour Math Awareness Week video on the Fibonacci sequence, chaos theory, and the golden ratio that I think you should look at. It's a really exciting topic in mathematics that a lot of students don't get to see at this level, but really they have the ability to understand everything in it. The questions that you get when you're working with recursively defined sequences they're basically the same as what you would get if you were working with a regular sequence. You're asked to list out so many terms. So in this case, we're given the following recursively defined sequence. A sub n is just equal to twice the previous term in the sequence plus 8. And they have to tell us one term to begin with, because if they don't tell us the initial term, then I couldn't say what the second term is because it relies on us knowing the first. So it's a chicken-egg situation. Somebody has to give me the initial value for this sequence so that I can use my recursively defined sequence here. So let's go ahead and do this. A sub 1, well, they told us that. That's 2. A sub 2, and remember, we're just listing out the first 5 terms. A sub 2 is going to be twice a sub 1 plus 8. Well, that's twice 2 plus 8, which is 12. A sub 3 is twice a sub 2, again, plus 8. That's twice 12 plus 8. That's 24 plus 8, or 32. And a sub 4, so you can do this for quite some time. I'm just going to go ahead and do this last one. Twice a sub 3 plus 8. That's equal to 64 plus 8, which is 72. And a sub 5 is twice a sub 4 plus 8. Now we're into some business. 144 plus 8 is 152. And I do want to state, every once in a while, I'll have a student that will ask, is there a way to write a recursively defined sequence in closed form? And what they really truly mean by that is there a format where you could just quickly find a sub n without having to compute all the previous values? There are times when you can do that. They're not that they're rare, but they're difficult to derive. So I won't do it here, but you will have some that you can derive closed formulas for. If you don't know what I mean by that, don't worry right now. We'll probably run into that in a little bit. This one is my favorite recursively defined sequence ever. This is the Fibonacci sequence. And it starts with the fact that a sub n, it's recursively defined, so a sub n is just the sum of its previous two terms in its sequence. Because each number in the sequence is the sum of the previous two terms, you cannot start the sequence without knowing two terms. So the definition for the two terms are going to be a1 and a2 are both equal to 1. So let's go ahead and find out what the first few, I'm not just going to stop at 5, I'm going to do the first few terms. So a1, well, that's 1. a2, well, that was defined to be 1 as well. a3 is going to be the sum of the previous two terms. That's 1 plus 1 or 2. a4 is going to be the sum of the previous two terms. That's 2 plus 1 or 3. a5 is going to be the sum of the previous two terms. And that is going to be 3 plus 2, which is 5. And now you can kind of just look up here, right? 3 plus 5 is 8. a7 is going to be 8 plus 5, which is 13. And you can keep going all day long, right? a8 is 13 plus 8, which is 21. And so on and so forth. A beautiful sequence that has a lot of mysticism associated with it. In fact, my birthday's coming up. One of my friends got me an old textbook from the early 1900s, about almost 100 years old. And I opened up the text and had to chuckle at the preface. It begins with, "In olden days." Now remember, this text actually was written in 1931. In olden days, mathematics was regarded as a part of magic, and at first, only priests and medicine men were allowed to use it. It's a great first sentence because magic and mathematics were often intermingled. And that was because there were a lot of properties of mathematics that would blow people's minds. And so, like I said, the Fibonacci sequence demonstrates one of those properties. It's very mystical. It's not actually magic. It's just anything that you don't understand seems magical until the moment you understand it and you're like, oh, okay. So imagine somebody from the 1400s showing up and seeing your iPhone. That's magic to them. But there's actually concrete, logical, technological explanations for what's happening within that device. And so to us, it's just a device. It's not magic. But to somebody who doesn't know, it is magic. And so opening your eyes, we are the mathematicians of the world. We are the wizards behind the curtain. And what we're trying to reveal to people is the magic that is not so magical, but is still very beautiful. But unfortunately, most people don't want to live their life with knowledge. They'd rather live their life in ignorance. All right, that mean statement said, let's go ahead and do an application here. And sequences and series do have a lot of applications associated with them. And so here's this one, a very common one. Margarita borrows $12,000 from her uncle and agrees to repay it in monthly installments of $700. Her uncle charges an 0.8% interest per month on the balance. If her balance, a sub n, in the nth month is given recursively by that sequence, a sub n is equal to k times a sub n minus 1 minus 700, where a naught is 12,000, what is k? First thing I should mention here, this is a sequence, a recursively defined sequence, and yet I have the first term called a sub 0. That is super common, actually. We don't always just restrict the indices for our sequences to start at 1. We are often starting at 0, in fact. So it's totally okay to have a sequence start at 0. The second thing you should know, there's a very important sentence here. Her uncle charges 0.8% of interest per month. Now, when most people read that, they think, man, that's a very low interest rate. No, that's not a low interest rate. That's a per month interest rate. Multiply that by 12 and the real interest rate would be given as, what is that, 9.6%? So this is actually 9.6% per year. And it's honestly even greater than that because he's charging interest upon interest. So it's roughly around 10% per year is what he's actually charging her. So just, that's a heads up. It's not a low interest rate. So the question is, what is K? How would you find out that value of K? Well, let's see. Suppose this is you. You borrowed 12 grand and your uncle says, you're going to give me $700 a month. You say, okay, that's cheaper than me just taking out 12,000 right now. And he says, by the way, I'm just going to charge you 0.8% per month. And you say, okay, that sounds super cheap, which it's not. And so then your uncle, maybe he's a mathematician, and he says, by the way, this is how you can figure out what your balance is. Okay, sounds good to me. So A sub 0, we know is 12,000. That was our initial balance. A sub 1 should be less than that because we will have paid off $700, right? Well, sort of. By the formula, A sub 1 should be K, which we don't know, times A sub 0 minus 700. Let's talk about each of these pieces. We know what A sub 0 is. A sub 0 is 12,000 minus 700. But what is the one piece we're missing here when we're computing our balance? It's not as if we took out a $12,000 loan and just paid back 700 and there was no damage. It turns out that we gained a little interest that we owe on that $12,000. So K here is going to pump up the true value of our debt by a certain percentage every single month. What is that value of K? Well, some people would say that K must be the 0.8%. Let's try that out. If you wrote 0.8% as a decimal, it would look like this. That's 0.8% as a decimal. I'm going to put a question mark here. Is this the same? All right, so let's see if that's the case. So remember, all you've paid off so far is $700. And grabbing a handy dandy calculator and computing this out, this would equal negative 604. There's something terribly wrong there. That your uncle loaned you 12 grand, you paid back 700, and now you owe him, well, actually he owes you $604. That does not make sense at all. So putting in the 0.8% there is incorrect. However, really what's happening is he's taking that $12,000 and he's increasing it by 0.8% to get a new balance, and you're going to pay down that. Let me at least do this in a slow version. I will take my handy dandy calculator here, 1.008, and multiply that by 12,000, just to tell you that right before you pay him your first installment, your actual balance is $12,096. That makes sense. You've earned 1 month of interest. You owe $96 to him just in interest. And so now your actual balance, when you subtract off these $700, is going to be $11,396. So that makes total sense logically, that a month later we owe a little bit more money because of interest, and then our payment goes partially to paying back that interest, that $96, and the rest of it pays the principal down a little bit. That's how real world loans work. So in this case, we can easily say, what is K? K is equal to 1.008. It is the increase in the balance due to the monthly interest rate. And find your balance after 11 months. Now here's the deal with this. If you want to find the balance after 11 months, you should probably grab a calculator. And I should mention that you don't have to always use a calculator for this, but it's probably best for this specific situation to use a calculator. So let's find the balance after 11 months. And I'm going to show you how to do this using a spreadsheet program. I find it's very important that people learn to use something like Excel or Google Sheets because you're going to need it in the real world. And so in this case, I just labeled the first row and column as N, which means what's the index of 0, 1, 2, 3. And the second column is labeled A sub N. Not that you need the labels, I just did it for my own personal enjoyment, right? And let's see, at time 0, Margarita owed $12,000. At time 1, we're going to go ahead and enter a formula. It's equal to, remember, it was 1.008 times the previous value. So I'm just going to go ahead and multiply it by this previous value. I just clicked on it. And then subtract 700. I hit enter, and that gets us to that 11,396 we saw earlier. Now you're more than welcome to say, oh, then the second one is equal to 1.008 times the previous value minus 700, but you're kind of wasting your time doing that. The power of a spreadsheet program is that you could just grab the lower right hand corner and drag, and that will basically take the pattern you've set up, which is taking this in the cell, taking 1.008 and multiplying it by the previous cell's value and then subtracting 700. It will copy that pattern all the way down if you drag down. And I'll show you another fast way to do it. But there you go. After 11 months of payments, Margarita will only owe $5,083.76 after 11 months. That's how you could use a spreadsheet program for this. By the way, just to let you know, just to give you some spreadsheet foo, if you already have a pattern set up, so this one is actually equal to 1.008 times the cell previous minus 700. If you already have that set up, and if you have the cells to the left numbered, so we have these cells numbered all the way up to 11, then rather than clicking and dragging, you could just double click on this lower right hand corner and it will automatically pre-fill all the way down to the last number that you have on the left there. So if you wanted to, let me go ahead and delete these and showcase that again. If you wanted to, you could say, well, I want this pattern. Let me continue this pattern down. Let's say I want to know how much Marguerite owes after, I don't care, 24 months. So I'm going to drag that down. All I did was I grabbed a couple, 3 cells, and then start dragging down. Once it sees those 3 cells I copied or highlighted, it knows the pattern. It's just going to add 1 to each number that I go below. So there are the first 24 months. Now if I just go up here and double click, it'll fill all the way down to the 24th month. This is an interesting situation because by the time it gets to the 18th month, Marguerite only owes $356.19. And so in the 19th month, she's done paying. This means that her uncle now owes her. So she would probably be done after the 18th month. She just, month 19, she'd pay off the extra $356.19 plus some interest. So anyhow, that's how you can use Excel to do a problem like that. And like I said, we've already answered the balance after 11 months, which was $5,083.76. And that is actually the final example on this lecture.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.